I'm going to show you two methods. You can choose how you like to do it. I'm going to cut out one of these lights so we can see a little better. So we're going to look at two ways we can add and subtract. We're going to look at adding and subtracting vertically. So when you start out adding 3 4-digit numbers, so like 4,227 plus 389, you started adding those vertically. And you line up your place numbers of your numbers, your ones, your tens, your hundreds, your thousands, so on and so forth. Well, one way to add or subtract polynomials is to add them by their degree. So you're not looking at necessarily their place values, like with numbers, you can add them together in degree columns. And this is setting us up for when we start doing long division with polynomials. We're going to get our degrees, the exponents of our variables, lined up. So you're going to want to look at both of your polynomials and look at what is the highest degree or the highest exponent you see when you look at both of these polynomials. So the polynomials are inside these parentheses. What's the highest exponent we see in both of those polynomials? X to the what power is the highest? X to the third. So we have some x to the third terms. X to the third. I'm going to make a column just designated for x to the third polynomial terms. Then we're going to go x to the second, x all the way down until we get to constant. So we're setting up these columns, and then now we can start putting in the terms that are the same degree. So now first, polynomial, I've got 3x squared plus 7 plus x. I do not have an x to the third term. No worries, I can just put a 0x to the third to represent that. So we don't have an x to the third, we could represent it with a 0x to the third. And we start getting into the polynomial division, that's just called a 0 term. We're going to put in a 0 term, it's not going to affect anything, but then it still fills in, we have that x to the third term. Then I look at my polynomial, I've got a 3x squared, it's positive, so I put a plus sign. I've got a plus x, and then I've got a constant plus 7. So there's our first polynomial. Now it's put into the column that's also in standard form, with the highest degree down to the lowest. You bet. Next polynomial, 10x to the third. That's going to go into our 10x, our x to the third column. So we got plus 10x to the third, x squared plus x squared, and we've got a minus x and a plus 2. So I'm always keeping whatever subtraction or addition is in front of my term. I'm keeping that as I shift these terms around. Now it's easy. All we're doing is looking at the numbers. We don't even need to worry about the variables. So the variables will work their way through. We're going to have an x to the third. We're going to have an x squared term, an x term, and then a constant term. All we're doing is adding now the numbers, which are called the coefficients. So you're doing 0 plus 10. That's 10. So we got 10x to the third. 3 plus, this would be a 1 in front of there. 3 plus 1 is 4. So we got a 4x squared. X plus negative x. Those are working against each other. So we got a plus 0x. And then 7 plus 2 plus 9. And we'll write that out then in standard form. We're going to have a 10x to the third plus 4x squared plus 9. So there would be our polynomial all added up, put into standard form. I did not put the 0x. If you put it, it doesn't do anything, so we're not going to put it in there. We just have our 3 terms. Something we talked about yesterday is classifying. You have a third degree, which means you have a cubic, and you also have 1, 2, 3 terms, which is a trinomial. So that's one way that we can add those together. For you guys in your notes, I would just make like a little barrier, and then the rest of the problem we can work on that side over there. For me, I'm going to erase that because I'm kind of running out of room. So you guys let me know, is it okay if I erase that, or do you want me to keep it up there a little? Sure? You guys didn't have much time. All right, we'll do another one so you get another one too. So I'm going to show the second method. So the second method, we can just combine like terms. So we've got a 3x squared right here. We're looking through, are there any other x squared terms? Yes. We've got a plus x squared right there. So I've got a 4x squared. Next, we've got a 7. Just going to underline the 7. That is a constant with 2. So that's a plus 9. We've also got an x. Let's put a square around that, an x and a negative x, which is going to make 0x. And lastly, that 10x to the third has nothing to go with, so we have a plus 10x to the third. So the second method, and sorry it's so small up here, but you can kind of look at your own, is finding where the x squared term that matches up. We can add those together, add the constants together, add the x with the negative x, get 0x, and then add that 10x to the third. The last thing then is put it into standard form, so we'll get 10x to the third plus 4x squared plus 9. So now we're back into that standard form. So I can add them in any order using the commutative property. I'm just going to find the terms that have the same degree. Now I can start to add those together. So I'm kind of leaving that up to you how you want to add them. You have two different ways that you can do that. So subtracting we'll take a look at next. Am I okay if I close this one down? Caden, you good back there?
Yeah.
Getting sleepy? Yeah. So again, same process with subtracting. We'll look at what is the highest degree. We've got an m to the third. So I'll put an m to the third, m squared column, an m column, and a constant column. So I look at my first polynomial. I do not have an m to the third, so I'll just put a 0, m to the third. That'll be my m to the third term. That first polynomial does have a m squared. It's a plus 4m squared. It does have an m and a linear term, 3m, minus 3m, excuse me, and then has a constant term plus 2. Subtracting, so I'm going to put a subtract sign over here. I've got a m to the third. Then I've got a minus 2m, so I'm going to put a 0 term in for the m squared. There is no m squared in that second polynomial. And I've got a minus 2m. And lastly, I've got a plus 5. So I'm organizing all my m to the thirds. If I don't have one, I'll put a 0 term in. My m squareds are all lined up. If I don't have an m squared, which I don't in this polynomial, I'll put a 0 term in. All my m's are lined up. So it just helps me get it organized. Then all I have to do now is just do the subtracting with the numbers. I don't need to worry about anything with the variables. The variables will just be part of my result when I add the two numbers together. And I'll put my line underneath to separate my answer. Subtracting does get a little tricky, so you got to be careful on how we're doing our subtracting to avoid mistakes. So I am subtracting 0 minus, and this would be a 1 in front of this m. I like to think of temperature. So if it's 0 degrees and you go down 1 degree, what's the new temperature outside? 0 goes down 1, where are we at? Negative 1. I'm just going to say negative m to the third, then would be that term. Next one, easy. 4 minus 0, 4. You take away 0, still 4. So that would be a plus 4m squared. Next, we got to use our integer patterns. When you do a negative 3 minus a negative 2, that's what I want to focus on. Minus a negative. What are you really doing when you're minusing a negative? 2 negatives in a row, what are you actually doing? adding. So this is going to be negative 3. Just make this simpler, plus 2. Negative 1. So negative 3, you go up 2, excuse me, you're going to be at negative 1, which I'm just going to say is negative m. And lastly, we've got 2, take away 5. So it's 2 degrees, it goes down 5 degrees, you're going to go down below 0, it's going to be negative 3. So there would be our result. It's already in standard form. You've got it from the highest degree down to the lowest. You're set to go. So negative m to the third minus plus 4m squared minus m minus 3. The other method you can do, you can combine terms. And to do that, this subtraction part right here, all subtraction does is it changes each of these terms inside. It changes them to their opposite. So in red above here, I'm going to show that. So this negative makes this its opposite, makes this one its opposite, and makes that one its opposite. So we're going to have a negative m to the third plus 2m minus 5. So what that minus sign does is it just subtracts, but it's going to change each of these numbers to its opposite. Now I can do like my method 2 from above. I can look to just combine terms. So I'm going to look to just combine. Negative m to the third has nothing else to go with, so that's just going to be negative m to the third. 4m squared has nothing to combine with, so that just comes along as plus 4m squared. And I got a plus 2m here. I've got a minus 3m here, so negative 3 plus 2, negative m. And a positive 2 combined with a negative 5 is negative 3. So we should get the same answer as we just had, hopefully. But that's the other way. You can think of each of those numbers after the subtract sign, just as their opposites. And then you're right back to just combining like terms, like we did in the problem above. So I'm leaving it up to you. If you want to line them up vertically, add them up, great. We'll end up doing it that way because we'll do that long division. If you want to just combine the terms, that also will work. Either way is perfect. So we're going to take a look at that last one here in a second. Are you guys okay if I delete this one? Okay, let's get that deleted, and then we'll take a look at our very last problem here. So polynomials are going to be used in finance quite a bit. So in finance, they can be used to measure profits, cost, things like that. So here's a company. This minus 1,500, minus 1,700, that represents a cost of getting a business going. So if you're starting your own business, whether it be like landscaping or painting, whatever it is, you're going to have to buy tools, you're going to have to buy machinery to get your business going. So that constant, that negative 1,500 represents your cost. And then the rest of the polynomial is going to represent how you can start accruing profits. Hopefully you can get above 0. But we're going to look at the profits of 2 manufacturing plants are modeled as the first polynomial, negative 300x squared plus 25x minus 1,500, and the second polynomial. Write a polynomial expression that represents the difference. This is our key word. This is going to tell us if we're adding or subtracting. So difference, adding or subtracting? Subtract the 2. So we are going to subtract. I'm going to use the combining like terms method. So here's our first polynomial, negative 0.03x squared plus 25x minus 1,500. Now when I subtract this polynomial, I can think of it as adding the opposite of each of these terms. So if I have a negative 2 cents right here, what's the opposite of a negative 2 cents? Positive 2 cents. So I'm going to have a plus 0.02x squared. If I'm subtracting a negative, it's the same as just adding 2 cents. So I'm going to have that. Opposite of 21x, negative 21x. Opposite of negative 1,700, positive 1,700. So since I'm subtracting, remember we're doing the difference, I'm subtracting this company's profits, I'm going to do the opposite of each of these terms. Now I'm ready to start combining my terms together. So first, we have a negative 3 cents positive 2 cents. So if you're at negative 3 cents and you add 2 cents, you're now at negative 1 cent. So there's your first part of your difference in profits. 25, negative 21. So basically just 25 minus 21 for x. And the negative 15, you add 17. So I'm not worried about the zeros. I'm just doing negative 15 plus 17. That's going to get me to positive 2. Add the zeros back on. Plus 200. So there would be my difference in profits. If you wanted to, you could line up your x squareds, you could line up your x's, line up your constants, or we can just do that subtraction by adding the opposite. So that finishes up lesson 11. Like I said, if you haven't seen the first part, just those first 8 minutes, and then you'll be all caught up. So I'm going to let you go and kind of check in with everybody. So the last 15 minutes are yours to do with what you need. And I will come around to check in if you need any help.